Hi guys. So in this particular video, we're going to go over everything that we need to know about factoring. Now this is going to be short and sweet and to the point. Factoring is one of those things that it does take several days worth of class to go over. So I'm just hitting the high points here, kind of giving you an example of everything that you might possibly see on your homework. If you need more help, of course, you can get in touch with me. I also have some notes posted. So one of the things, let me just go over this right quick. So they're asking us to factor each polynomial, and then if a polynomial cannot be factored right prime, we want to factor out the greatest common factor as necessary. So I'm going to go to some notes that I have posted on your Moodle page. So let me get rid of factoring here. So these are notes that you're going to find. This is your step-by-step process of how to factor out everything. So when you're factoring, the first thing that you want to do, so this is the strategy for factoring. The first thing that you always want to try to do is factor out the GCF if possible. Now, the GCF is the largest number that will divide into each term and the variable with the smallest exponent, as long as all terms have that same variable. So that's our first step. The second step is going to depend on whether you have a binomial, which means that you have two terms in you're asked to factor. You have a trinomial, which means you have three terms, or you've got four more terms. So if you've got a binomial, you're going to check for a difference of squares, which is this rule right here. So if it fits this pattern, that's a difference of squares. Or you're going to check for a sum or difference of cubes. Now that fits these two rules here. So that's what you're looking for. You're looking for whether you've got squares or cubes. Now, one of the things I want to point out here is with cubes, you do have the option of doing a plus or minus in between the two. You only have a difference of two squares. So if you have two squares, but you've got a plus sign in the middle, that is a sum of two squares. And for us, that is prime. The reason it's considered prime is because it actually factors out into imaginary numbers, and that's not part of our curriculum. So we are going to get a prime answer there. And then if you've got a if the binomial isn't one of these three options that we had here, the difference of two squares or sum or difference of two cubes, you are done. You can't factor it any further. That's with a binomial. Now with a trinomial, after you've checked to see if you have a GCF, you're going to use the factoring by grouping method and factor accordingly. And if that's not possible, then you're done. There are two perfect square trinomial rules here. So if you're given something that looks like this or like this down here, they can be factored out into a plus b squared, a minus b squared. Again, guys, as you saw in one of the previous videos, there is no reason to memorize these rules. I mean, you know, it's a little bit quicker to factor if you recognize it, but there are other ways to do it that always work. So you don't have to go in and test to make sure you've got a square term on the end of the trinomial and a 2ab in the middle. So I'm going to show you a different way of doing that. It's actually going to be kind of the same method that we're using if you've got four or more terms. So if you've got four or more terms, we're going to do factoring by grouping. There is a list of steps how to do factoring by grouping right here. Rather than reading these out, I'm just going to show you how to do it. And then finally, you want to check your final answer to make sure it's factored completely. So again, these notes will be on your Moodle page. You're more than welcome to pull them up and look at them. So let me go back here. Actually, I'm just going to stop share and we are going to go to a whiteboard. I've got the problems wrote down that I want to go over. Oops. Oh, let me clear this out. Go away. All right. So the first problem that I want to look at, this is actually number 2. It does not like when I write too high on this screen. Number 2. There we go. So they give me 3y squared plus 24y squared plus 9y. All right. So if I look back at the notes, my first step is to look for a GCF. So a GCF, oops, nope, I wrote this wrong. This is a 3y cubed. Sorry. So a GCF means I'm looking for the largest number that's going to divide into every number that I'm seeing, and then I look for a variable. As long as they all have the same variable, I look for the smallest exponent. So when I look at 3, 24, and 9, I see that 3, 24, and 9 are all divisible by 3. So my GCF is going to be 3. And then if you'll notice, every single term that I see has a y. So I can take out the smallest exponent. Well, I've got a cubed, I've got a square, and then this is actually an exponent of 1. So I'm going to take out a 3y. So there's two ways that you can look at this, and it just depends on what you're more comfortable with doing. You can divide every single term by 3y. So I can do 3y cubed divided by 3y is y squared. And then 24y squared divided by 3y, 9y divided by 3y. If division is not your strong suit, that's fine. You can also look at it as multiplication. And I actually think looking at it as multiplication is much easier to do. So what I'm going to say to myself is, okay, what would I have to multiply 3y by to get 3y cubed? Well, 3 times 1 will give me 3, right? So don't have to worry about the 3. What do I have to multiply y by to get y cubed? Well, that would have to be a y squared. Remember, when you're multiplying, your exponents need to add up. So I get y squared. Okay, let's try it again. What do I need to multiply 3y by to get 24y squared? Well, 3's got to be multiplied by an 8, and it's a positive, because a positive times a positive will give me a positive. 3y's got to be multiplied by an 8 to get 24. And y needs to be multiplied by another y to get y squared. Okay. And finally, what do I need to multiply 3y by to get 9y? Well, we've already got the y, so I don't have to worry about the y's. 3 times 3 will give me 9. Okay, so we have factored out the GCF. So now I need to figure out, is that y squared plus 8y plus 3 factorable? So that's a trinomial in my parentheses. So if I go back to my list and look at my trinomials, I'm going to attempt to do the grouping method. And I'm just going to go ahead and tell you this isn't going to work. And the reason it's not going to work, let me write out a little thing here. So this is ax squared plus bx plus c. That's a standard definition of a trinomial. So the way that the grouping method works is I'm supposed to take a times c, and it needs to add to be b. Okay, so what does that mean? Well, here my a is a 1, my c is a 3, so I'm going to do 1 times 3 and get 3. So I'm looking for factors of 3 that are going to add to be b, and my b is an 8. So factors. So are there any factors of 3 that add to be 8? So when I say factors, what can you multiply together to get 3? Well, I can multiply 1 times 3, right? That's pretty much it. So 1 times 3, if you add those together, you are not going to get 8. You're going to get 4. So what that tells me is, no, this doesn't work for this particular problem. So this is my final factored answer. So 3y times y squared plus 8y plus 3. I can't do anything else with that. All right. Now, I know it was confusing kind of seeing this AC method. So, or factoring by grouping, either way you want to call it, or either thing you want to call it. So I'm going to go back over a different problem. So let's do another one. So that's factoring out the GCF. Okay, so we're going to look at number 10. So I have s squared plus 2st minus 35t squared. Okay, so the first thing I want to do is I want to look for a GCF. That's always your first step. So I see some S's and I see some T's, which is great, but not every single term has an S, nor does every single term have a T. So I can't factor out an S or a T. And then if I look at my coefficients, my S squared has a 1, my middle term has a 2, and my last term has a negative 35. I mean, you could divide everything by 1, but it doesn't change anything. So this particular problem does not have a greatest common factor. It does not have a GCF. So what I'm going to do is, because I've got 3 terms, I am going to go with factoring by grouping. So again, let me write out. So the definition of a trinomial is ax squared plus bx plus c. So I am looking for factors of a times c, and those factors need to add to be b. Now, as we're contemplating this, one of the things I do want to mention is, no, you do not have to, oh, it's in the way there. You do not have to do it this way. If you have done the check and get, or the trial and error method, that's fine. There's something called a diamond method that you could use. There's a bunch of different ways to factor trinomials. I like the AC method. I like the factoring by grouping, because if you've got 4 terms, this is the exact same way you're going to factor a problem with 4 terms. So if I do a times c, my a here is going to be a 1. So I'm going to do 1 times negative 35. So I'm looking for factors of negative 35 that are going to add to b. My b term is a 2. So factors of negative 35 that add to be 2. Close this. Will that make it go away? Oh, cool. Okay. So let's go through our list of factors of negative 35. Now, one of the things I'm going to point out here is, as you do this more and more and more, you're going to get quicker and quicker and quicker at finding these factors that add to be b. I'm going to write them all down just so we can look at them, and then we'll discuss which ones are going to work for us, and then we'll go from there. So if I look at my factors of 35, I've got 1 times 35 is 35. 2 won't go, 3 won't go, 4 won't go, 5 will go. So 5 times 7 will be, that gives me 35. All right, so here's the problem though. I need these factors to be negative 35. So what that tells me is one of these factors needs to be negative and one of them has to be positive. Now, which one has to be negative and which one has to be positive is completely dependent on what you're adding to. So I'm adding to be a positive 2. So let's look at our first set of factors I have here, 1 and 35. There is no way to manipulate 1 and 35 and get it to add to be 2. So if I make 1 negative and add it to 35, I get 34. If I make 35 negative and add it to 1, I get negative 34. So these don't work. I'm going to throw them out. So 5 and 7, we're hoping it does something for us. So if I make 5 negative, negative 5 plus 7 is going to give me a positive 2. So that's my 2 factors. If you made the 7 negative instead of the 5, you'd end up with negative 2, and I need it to be positive 2. So one of the things that we're seeing here is that signs do matter. You do have to pay particular attention to what you're trying to add to be. So my 2 new factors are these. So what I'm going to do is I'm going to rewrite this problem, but instead of using 2st, I'm going to replace it with these 2 new factors that I just come up with. So you're going to bring down your first term. We don't change that. The second term, I'm going to change it to be negative 5st plus 7st. Notice that my negative 5 and my 7 get this st that was attached to the middle term. Bring down my negative 35t squared. Okay, now one of the things I want to point out here is you actually have not changed this problem. Negative 5st plus 7st, if you were to combine like terms, it would end up being a 2st. However, you have taken a trinomial and suddenly made it be 4 terms. Now, something really cool happens when you have 4 terms. We can group, and that's what I'm going to do. Now, I'm going to change my pen color to a blue. And here's what I want you to understand. This grouping that is about to take place, I am doing it in my head. That's why I do it in a different color. So this is what I'm seeing in my head. I'm going to group the s squared minus 5st is 1. So in my head, I see those 2 things going together. And then I'm going to group this positive 7st and the negative 35t squared. I see that in my head. So guys, this is not a multiplication problem. Remember, the blue is just what I did in my head. So let me switch colors. So what I'm going to do now that I've got two groupings is I'm going to see if I can factor out a GCF from these two groupings. And I think I can. So in that first grouping that I have, s squared minus 5st, they both have an s. So I'm going to factor out an s. So if I factor out an s, that's going to leave me with s minus 5t. All right, cool. Now in the second set of grouping that I've got there, I always take the sign that I show up front. So in the second set in my head, I had a plus. So I'm going to factor out a positive. And then 7 and 35, I can take a 7 out. And then they both have a t. So if I take a positive 7t out, that's going to leave me with s minus 5t. Now notice when you take a positive out, your signs don't change. I've still got a positive, still got a negative. If you were to take a negative out, and we will look at one of those, hopefully. Maybe not. I don't know if I've got an example of that or not. But if you were to take a negative out, you would see these two signs change. And that's cool. There's nothing wrong with that. But one of the things I want to point out here is I know I've done this process correctly. And the reason I know that I've done this process correctly are these two parentheses match. So the lovely thing about factoring by grouping is it tells you whether you've done it right or not. So if you ever do this and you get two completely different sets of parentheses, something is wrong. Go back and check your math. You've got a negative or something's off. It's not, there's a problem somewhere. And because these two sets of parentheses match, what I'm going to do is I'm going to look at this like it's a term, and I'm going to look at this thing like it's a term. So just like I did up here factoring out the GCF, I'm going to see what's common to both of these terms. And what do I see? I see an s minus 5t in both of them. So I'm going to factor out an s minus 5t. And when I factor out that s minus 5t from this thing, that's going to leave me with an s. And when I factor out an s minus 5t from this thing, that's going to leave me with a positive 7t. And there we go. That is completely factored. Now, the awesome thing about factoring too is that you can check your work. If I wanted to check it, I'd just multiply it back out and see if I get the same thing I started with. All right, let's see. I really want to get a negative in here, so let's get a negative in. I'm going to clear this. Let's do 14. So number 14. Same thing, I'm factoring. Give me 15y squared plus y minus 2. So first thing I want to do is I want to check for GCF. I definitely don't see a GCF. Not every term has a y, and there's nothing that's going to come out of 15 or 2 that's the same besides 1. So let's move on to, this is a trinomial, so I'm going to factor by grouping. So I'm going to do a times c. So a times c is 15 times negative 2. So I'm looking for factors of negative 30 that are going to add to be my b term. Now, the b is whatever's in front of your middle term here, and that's a 1. So factors of negative 30 that add to be 1. We could do negative 30 times 1, or excuse me, negative 30 times 1, which is not going to, I'm not going to get to 1. So if I go through my factors, 30 times 1, 15 times 2, 10 times 3, 6 times 5. And one of the reasons I'm writing this way, it looks a little weird. It doesn't matter if you do 1 times 30, 30 times 1. Again, multiplication is commutative. Okay. So, looking at this, I think the only way that we're going to add to be 1, 31 is not going to do it. 15 and 2 is not going to do it. 10 and 3 is not going to do it. It's got to be 6 and 5. Now, notice we are multiplying to be a negative 30. That means that one of our signs needs to be positive and one of them needs to be negative. Which one needs to be positive and which one needs to be negative is completely dependent on what you're adding to, and I'm adding to be a positive 1. So if I make 6 negative, negative 6 plus 5 is going to give me a negative 1. That's not good. So let's make the 5 negative. So 6 plus negative 5 is definitely going to give me a positive 1. This is my 2 factors. Now, one of the things I want to point out here is I rewrite this because that's our next step with the factoring by grouping. Is it doesn't matter how you put these in, what order you put them in, because addition is also commutative. I'm purposely going to write it as a positive 6y minus 5y because I want to be able to show you what happens when you factor out a negative. So you've taken a trinomial, you've changed it to be 4 terms. You've not actually changed the problem because positive 6y minus 5y is still a positive 1y. But I'm going to group. Again, this grouping I'm doing in my head. So because I've got 4 terms, I'm going to put the first 2 terms together. I'm going to put the second 2 terms together. That's what's going on in my head. So I'm going to try to factor out a GCF from each one of these groupings. So what can I factor out of both the 15 and a 6? Well, that would be a 3. And y squared and y can give up, or they can both give up a y. So if I factor out a 3y, that's going to leave me 5y plus 2. Now in the second set, well, I have to take something out. You have to have something between these 2 sets of parentheses. They don't both have a y, so I can't take out a y. 2 and 5 really only has one common factor, and that's going to be a 1. Now, because the sign up front is a negative, I'm going to factor out a negative 1. And what you're going to see happen is you're going to see both of my signs change, because what would you have to multiply negative 1 by to get a negative 5y? Well, that would have to be a positive 5y. And what would you have to multiply negative 1 by to get a negative 2? That would have to be a positive 2. Oops, a pen stopped. There we go. A positive 2. So I'm feeling really good about what we have done here, because if you will notice, I have a 5y plus 2. I have a 5y plus 2. If these 2 parentheses do not match, you have done something wrong. So I'm going to look at this like it's a term, and I'm going to look at this like it's a term. So what's common to both of those? The 5y plus 2. So I'm going to factor out. What's going on with my pen? There we go. I'm going to factor out a 5y plus 2, and that's going to leave me from this first set, that's going to leave me with the 3y. And from this second set, that's going to leave me with the minus 1. So this completely factored is 5y plus 2 times 3y minus 1. All right. So that's another factoring by grouping. Guys, after you do this process maybe 4 times, you're going to realize, oh, wow, it's the same thing over and over and over again. Again, if you've learned it a different way, that's fine. There is nothing wrong with doing it your way. Just make sure the answer always works. All right, let's switch gears a little bit. I'm going to look at number 22. So number 22, 9m squared minus 25. This problem is significantly different from the other problems that we have done because I no longer have a trinomial. This is a binomial. So again, even though our number of terms has changed, we still do the same process. So do I have a GCF? So every single problem starts out that way. And no, I don't have a GCF between 9m squared and a negative 25. So the next thing that I'm going to do is I'm going to look at what are my possible steps for a binomial. And if you'll notice with a binomial, if you go back to our note sheet, there was only 3 options. It's either a difference of squares, a sum of cubes, or a difference of cubes. Now, a real good indicator of whether it's going to be squares or cubes is this thing. A2, of course, is a squared. Now, it's not always that easy if you've got like 6s, because if you've got exponents of 6, that's both a sum of, or a difference of squares and a cube. So, you know, with the 2, it's pretty easy. So let me write my rule down here. So it says if you've got a squared minus b squared, that's equivalent to a plus b, a minus b. And if it's backwards from the way I've got it wrote on the paper, if it's a minus b times a plus b, it's the same thing. Don't worry about it. You just have to have a plus and a minus. So let's change colors. What I'm going to do is I'm going to come in here and I'm going to say, all right, what would I have to square to get 9m squared? So what would I have to square to get 9? Well, that would have to be a 3. And what would you have to square to get an m squared? That's an m. So what this represents is my a value. All right, let's look at the 25. What would you have to square to get 25? That would be 5. So that's b. So once you figure out what it is you're squaring, once you figure out your a and your b, you just plug it into this statement. So I have a plus b, so a was 3m plus b, 5. Then I've got a minus b, so I've got 3m minus 5. So this is a difference of two squares. Guys, a difference of two squares will always factor out this way. All right, cool. Let's do one more. So I'm going to clear this. Let's look at number 24. So number 24, they give me 9x squared plus 64. Again, just like any other problem, my first step is to look at, do I have a GCF? And unfortunately, no, we do not have any GCFs. So I can't factor this one with a GCF. So my next step is to look at my binomial rules. So I can either do a difference of squares or a sum or difference of cubes. Now, I'm pretty sure we're going to be working with the square stuff because we've got a 2. Now, there is a slight problem with this, though. A lot of students will go in and they'll go ahead and factor this out to be 3x plus 8, 3x minus 8, and that is incorrect because remember, your rule is a squared minus b squared. It's a minus. You have to have a minus. Do we have a minus here? No. So what does that tell me? This is not a difference of two squares. This is a sum of two squares. And if you look on your note sheet there, if you have a sum of two squares, it is not factorable. So the answer to this one is actually prime. I can't factor this into real numbers. It doesn't work. All right, guys. Again, this was just a brief synopsis of what happens with factoring. I hit the high spots. If you have questions, feel free to let me know.